we looked at mixtures. We said that our mixtures can be placed into two categories. Can you remember what are those categories?
Homogeneous mixtures and heterogeneous.
Good. Homogeneous mixtures and heterogeneous mixtures. We said also that there are various methods that we can employ in order to separate, or different methods we can use to separate these mixtures. Can you remember one of these methods of separation that we can use?
Evaporation.
Evaporation. Good. So we know if we have a mixture of oil and water, we want salt and water, and we want to separate it and retain our solid, which is our salt, we can use evaporation. Alright? So for today's class, we will be looking at miscible liquids. We will examine which separating technique we can use to separate them, and we will also demonstrate how we can separate our mixture using this particular method of separation. Alright? Good. Oil and water. Do you know how we can separate oil and water? So, in order to separate oil and water, we will have to use the separating funnel, and that is our topic for today. Alright? Good. So, oil and water, we can use the separating funnel. So here in these beakers, we have 25 ml of water and 25 ml of oil. What I want you to do is add the oil to the water. Now why are you doing it? So mix the two. Place the oil in the water.
All of it.
All of it. Good. And mix it well. Mix it in as much as possible. Does it mix it?
Yes.
It is?
No, it's
You
not.
sure?
No, it's not.
Not even a bit?
Not even a bit.
Alright.
Because we still see the other separated from the water.
Good. So oil and water are known as immiscible liquids. Alright? So we notice that we mix them in, and no matter how much we try, they are not combining. Alright? What I want you to do for me is write a definition in your own words about what you think immiscible liquids are. Now that we have tried to mix our water and oil together, what are you observing? What observations are you seeing?
I observed that the oil is separated from the water because the oil is on the top of the
You sure? Try mixing it some more. So it's still not mixing.
No, it's not.
Alright, can you tell me where else outside of today have you seen this happening? You've seen oil or any other liquid settling or not mixing in with another?
In my drink manager.
You sure wayside in your drink?
Yes.
And you've seen this?
Yes.
Alright. So oil and water, we said, are known as immiscible liquids. And from the little experiment that we did, we realized that oil and water do not mix. So with that, can you define immiscible liquids for me in your own words, in your book, please? Good. So can you tell me what is the definition you came up with for immiscible liquids?
Liquid that doesn't mix together.
Good. Immiscible liquids are liquids at, we have defined miscible liquids. Now we will move on to look at our separating funnel. So this is a separating funnel. So this is our tripod stand, and in order to use the separating funnel, we will need to set it up on some type of stand so that it can work effectively. So, just like any apparatus, our separating funnel has various parts. So here we have the topper, and this acts as a lid to keep the funnel closed. Here we have the stopcock, and this acts as a pipe knob to open and close. So when it is horizontal like this, it means that it is closed, and when we turn it vertically, it means that it is open.
So it have a hole?
Yes, it has a hole.
Okay.
Good. So let's examine our liquid again. So we mixed it, our mixture, and we noticed that the oil is at the top and the water is at the bottom. Have you ever wondered why not have the oil at the bottom and the water at the top? Because you said you would use waistline at home, and you noticed that the waistline would be at the top. Why not at the bottom and leaving the water at the top?
I have thought of that already. I don't think I know.
Good. So what happens, there is a difference in density between our liquids. So the liquid that has that's less dense will normally settle at the top of the liquid that is more dense. Alright? So in this case, our less dense liquid is
The oil.
the oil, because it's at the top, and our liquid that is more dense is our water. Question: when we add, because in order to separate our oil from our water, we will have to add it to our separating funnel. Do you think the position between the oil and the water will be switched when we add it to the separating funnel? Because this is a fancy looking apparatus, right?
Yeah, I think so.
You think it would?
Yes, because I think that the water will come out first and the oil.
You think the water will, so will the water be at the top of the funnel or at the bottom?
At the top.
The water will be at the top.
Yes.
Alright, so it's going to switch position in relation to how it is here. Because the water is at the bottom. So you're in the beaker, our water is at the bottom, but you're saying when we add it to the funnel, the water will be at the top of the oil?
Yes.
Why? Why do you think?
Because this is a beaker and it's flat surface like, and this is a separating funnel. So it's like
Because of the fact that it's hanging,
yes.
you think it would change?
Yes.
So the density would change.
No.
But how the density? But so if the density doesn't change, why would the position change? Wouldn't the oil remain at the top of the water because it's less dense?
Because of how you're turning it.
Sure.
Not 100%, but
That's the idea.
yes.
Alright. So I'm going to distribute some labels to you, and you are going to label the funnels. Alright? Good. So the first one is the stopper. So you have the stopper. You're going to tell me where in the funnel the high density liquid will be, where in the separated funnel we will have the low density liquid, and you're going to identify the stop cup as well.
Okay.
So you can do it one at a time.
So the door.
Yes, go ahead and do it. Wonderful. Label the various parts of our separated funnel. We will move on to demonstrate how we separate our oil from our water or our water from our oil. Alright. So we're going to remove our stopper. We will have to insert our funnel. Then we would need to add our mixture to our separating funnel. But before we add our mixture, we must make sure that our separating funnel is closed, meaning that it's close to water being water vacuum. Alright? But so I said before, in order to know that our funnel is closed, our stop cup would be vertical, and when it's open, it's horizontal. So, is it open or closed as it is, Ms. Hussein? So it means we need to know the difference between vertical and horizontal.
I know the difference between vertical
Alright?
and horizontal. So, it's closed.
You sure?
Yes.
We know that our separating funnel is closed. Now, can you add our oil and water to our funnel, to our separating funnel? Alright, remember when we're pouring, we always pour using the spout, right? So, then we remove our funnel, and then we have to close. So what we have to do is allow the mixture to settle for a while, because if you just mix it, we added, we saw that it mixed again a bit. So we have to allow it to settle before we actually allow it to separate. Right? Now that our mixture has settled for a while, in order to separate our oil from our water, we are going to open our tap slowly, allow our water to drain, to run out. We tried our best to capture just the oil in our funnel using our stop cup. Alright? So we're going to open it a bit. See what we're doing there? So we're going to do that until all the water runs out, just leaving our oil. Try it. Continue, Apple. Stop. Good. Good. So, let's see if we can release some. Good. So what we should have in our beaker is our water with our oil still remaining in our separated funnel. Alright? Good. Conduct a quick recap of the objectives that we have touched thus far. Alright? After our lesson now, we are going to do a little activity. So we have 3 mixtures on the board. What I want you to do is identify which one of these mixtures are immiscible or is immiscible.
Get chocolate.
allowing the mixture
to pass through.
to
Um, stopper,
Alright. So, homework. Give two other examples of immiscible liquids.